Okay, so let's talk about Splunk instances and components. In current practice, if you want to install an application today, what you typically do is to download the package that corresponds to the application and install it on your machine. It's as simple as that. With Splunk, this is not very different. So you can go to splunk.com and then you're going to see your package there, download that package and install. But what you get in this specific case is what we call a trial version of Splunk, which has some limitations because you are just basically trying it. It's like for testing. So you're going to have a period that is going to be available for you, with all the features open, and then you're also going to be limited in terms of the volume of data you can ingest in a day. Now, if you want to get a full-blown commercial installation of Splunk, which is going to be characterized by how much more data you can ingest in a day or you want to ingest in a day, how many users are going to be connected concurrently, what are the number of and type of searches that you're going to be running as you have that your deployment, then in that case the recommendation is to speak to Splunk sales. We're going to see this when we talk about Splunk deployment. So all this boils down to is a package. So you're going to have a package, and in our case, we're going to limit this just to the trial package because that's what we're going to ultimately install. So when you have that package in Splunk, you download it and then you install. And again, as we said, you're going to have a trial package or a commercial deployment. Now, what are the machine types that you can install this on? The first one comes here. You can install Splunk on a physical machine. So it could just be a physical server or your laptop. The second option is that you can actually install Splunk on a virtual machine. So if you have a virtualized infrastructure, being it on your premises or in the cloud, you can install Splunk on that as well. Or if that infrastructure, the operating system is virtualized as well, then you have a containerized infrastructure. So you can also install Splunk in a container. Note that these cloud concepts, I'm just bringing it up here to show you that you can install Splunk on these different machine types, but it's not really necessary for you to have a complete understanding of Splunk. So when you take that package and install on a machine, what you ultimately get is what we call a Splunk instance. So if you took a package and installed on your laptop, then you now have a Splunk instance on your laptop. But it's not very clear to you yet what that instance is going to be doing for you. That is why we talk about configuring those instances. So you can then configure those Splunk instances to perform specialized tasks. And this configuration that you do in order to get configure the Splunk instances what leads to the Splunk components that we spoke about in the previous video. So you can actually configure your instances to act as processing components of Splunk. It could be indexers, forwarders, search heads, or you can configure them to act as management components, which are listed here from deployment server to the monitoring console. But one of the things that you have to note, which is very important here, is that when we talk about this configuring Splunk instances to act as Splunk components, it's not a one-to-one mapping. So you can actually take a Splunk instance that's on your laptop, for example, and you configure it to act as an indexer, a search head, a deployment server at the same time. So you can configure one Splunk instance to function as multiple Splunk components. Okay, let's start our discussion of Splunk components with forwarders. Forwarders are the Splunk components that you install on your source machine. And what is the role of forwarders? Their role is to collect data from that source machine and send the data into Splunk. So let's suppose that you had data sitting in some files and directories in your machine and you thought, okay, I want to analyze this data in Splunk. So you go into that host machine, you install a forwarder there, and then you can configure that forwarder to collect that data and send the data out into Splunk for indexing. And note that forwarders are the primary way for you to send data into Splunk, but this is not the only way that you can send data into Splunk. As a matter of fact, there are multiple ways. As you continue your journey in Splunk, you're going to see apps and add-ons that you can use to ingest data, things like HTTP event collectors. So there are multiple ways that you can send data into Splunk, but just note that using forwarders is a primary way, and this is what is heavily used in commercial installations. Now, when you have your data in Splunk, the data is obviously going to be indexed. We're going to talk about indexers in the next slide, but what you ultimately want to do is to be able to connect to Splunk and then, as a Splunk user, and then search, analyze, and visualize this data. There are two types of forwarders. The first one, that is the most used one, is what we call the universal forwarder. So the universal forwarder is a separate executable with reduced functionality. What does this mean? We just spoke in the previous slide about you going to Splunk and then download a Splunk Enterprise package, installing it, get a Splunk instance, and then that Splunk instance can act as multiple Splunk components based on configuration. Now, when you go into the Splunk website, universal forwarder exists as a separate package. So for universal forwarder, this is different. You're not going to install Splunk Enterprise and configure it to become a universal forwarder. If you want to install a universal forwarder, it's a separate package. You just have to download that and then you install it on your source machine and configure to send data to Splunk. And then that's only its main function. So it doesn't have anything else. The main function is just to collect that data and send. The second one is what we call the heavy forwarder. So heavy forwarders are configured from a full Splunk Enterprise installation. So we saw in the previous slide that you can download a package of Splunk Enterprise and install that package on your machine. Now, if you wanted to have a heavy forwarder, then you configure this instance to become a heavy forwarder, which is different from the universal forwarder because it's a separate package. And then another important thing with heavy forwarders is that it can pass or make other changes to the data before forwarding the data out to Splunk for indexing. With a universal forwarder, it's very simple. You just collect the data and send. But with the heavy forwarders, you can make changes to the data. You can actually pass the data. So meaning that when you get your data, which is just going to be blocks of information, you can actually break this data into separate events. That means passing the data, and you can make other changes to the data as well before forwarding the data out to Splunk for indexing. So those are the main differences between universal forwarders and heavy forwarders. We saw in the previous slide that you can install forwarders on your source machine, so your host, to collect data and send this data into Splunk. You can use other methods to do this. Now, when that data gets into Splunk, the data is received and processed by the indexer. So that's the first thing that happens within Splunk. And what is this processing really? What happens during this process? There are a few things that can happen here. So you can actually pass the data. Remember, we saw that heavy forwarders can actually pass data. So they can break your data into separate events. If your data came in unparsed, maybe you sent it using a universal forwarder that doesn't have the ability to parse the data, then the indexer is going to have to parse that data. So it's going to break that data into separate events. Another thing that you can do during that processing as well is that you can assign metadata. So if you're sending data, you can say that this event is coming from this host, it is coming from this source, it is coming from this source type. So those are metadata that can be assigned to that as well. As we continue the journey in Splunk, again, we're going to see how you use all this metadata within Splunk itself. And another thing that can happen during this processing is that the indexer can assign timestamps, amongst other things that the indexer can do. So when all that happens, then the indexer writes the data ultimately to disk. That data in disk is organized into different repositories, and these repositories are known as indexes. So it is very, very important to get the distinction. The indexer processes the data and then saves the data into repositories in disk, which are known as indexes. So in the nutshell, we are saying that the indexer processes and writes incoming data into repositories known as indexes. Now, let's look at some examples of indexes. When you install Splunk, let's say you install your trial package of Splunk. Splunk comes with some indexes by default. So the main index, for example, is a default index. If you install Splunk and then you just started indexing some data and then you never specified an index where you want to put that data, then it's going to put that data in the main index because that's a default index. There are other default indexes that start with the underscore, like you see the underscore internal here, for example. These are known as internal indexes, and they are meant for Splunk's own internal logs. And then you can also define your own custom indexes. So let's suppose that you wanted to ingest Linux authentication logs into Splunk, and then you wanted to have a separate index for those logs. So you can go within Splunk and then you create a new index and maybe call it Linux, or maybe Linux Auth, or maybe Linux Authentication, a nice name that you can give to that index. And then when you are ingesting this data, you can actually point the data to go into that index. So when that data is ultimately in Splunk, you want to search the data, then you can specify that you want to search data from that index. So basically, you can define your own custom indexes. Now let's look at the structure of an index. That index that we saw, that are repositories in disk, when you start diving into that index, you're going to get some final repositories or files there. Those are known as buckets. So buckets are the final repositories within the index structure that contain the actual files that have the index data that you get into Splunk. So it's almost like you get into your machine, you get into Windows, for example. You get into one folder, you get into another folder, you get into another folder until you eventually get to the final folder that contains the files that you are looking for. So those final folders or repositories that contain the information you are indexing are what we refer to as index buckets. Now, what are the kind of buckets that you can see within the index? The first one is what we call it the hot and warm buckets. They are found in the home path. So first of all, you have the home path repository. And when you go deep into that, you're going to find hot and warm buckets. Hot buckets are buckets that are actually, when you are indexing your data into Splunk, is actually writing that data into the hot buckets. Now, after some size or time constraints, you can say when when the bucket gets to a certain size, or if it doesn't get to that size and gets to a certain time, that bucket is going to roll over and become a warm bucket. And then again, after certain size or time constraints, that warm bucket can roll over and then become a cold bucket. But note that as you are ingesting data into Splunk, data can only be written into the hot bucket. But if you want to search data, you can search both the hot, the warm, and the cold buckets. Now, when this data is in your cold bucket, is it going to stay there forever? You don't have unlimited storage, right? So obviously, you're going to have to specify that the data can stay for this amount of time. And if you say, for example, you wanted to keep that data for 90 days or for 6 months or whatever, then you're going to specify that. After that 6 months, then the data is going to be referred to as frozen. When it gets to that point, it's frozen. And then what are you going to do then? There are two things that can happen here. When that data is frozen, you can actually delete the data. Maybe you realize that, okay, after 6 months, I don't need it again. Or you might decide to archive the data. There are in some cases where you have governance requirements, for example, that are going to maybe want you to have your data stored for like, a couple of years, maybe 2, 3, 4 years or so. But you don't have that storage in order to do it. So you have to archive that data, and you archive that data in an external storage somewhere. The data is just there. And if in the future you wanted to like use that data, then you can actually go back to the archive and then unarchive that data. In that process, that data is referred to as being thawed. And so when you thaw the data, you get it back now into the thawed path, and then that data is going to be available again for you to search. Now, if you have just one indexer, and God forbid something happens, the indexer becomes inaccessible, it breaks down, and then you are unable to access your data in disk. So what's going to happen then? You don't have access to your data set. So in most commercial deployments of Splunk, where data availability is key, what you want to do is to take multiple indexers and group them together so that we have data replication between them. Data replication just means that if one indexer is indexing data, it makes sure that it sends a copy of that data to another indexer, a copy of that data to another indexer, so that as you are indexing, that data is available, on disks that are associated with multiple indexers, so that if one indexer fails, then you still have access to the same data set. So when you do this kind of grouping, that is what we refer to as an indexer cluster. So you actually group indexers together to provide data replication across the different indexers. And when you do this kind of configuration, then you have a special management component that we spoke about already, known as the indexer cluster manager. And the role of the indexer cluster manager is to coordinate those replication activities. Make sure that the data that you are ingesting is being replicated correctly across the indexer, so that if one indexer fails, you still have access to the same data set. It's going to look like nothing actually happened. And it also manages the cluster. So in the previous two slides, we've seen that we can use forwarders to forward data from your source host into Splunk, and then the indexers can index, process the data and write the data into disk. So what is left now is for you to search the data. And the Splunk component that helps you to search that data is what we call the search head. So you connect through the search head in order to send your search request to the indexers and then retrieve results and present to the user. So in the nutshell, what we are saying is that the search head, it does search management and presentation for results that you retrieve from the indexers, and then it distributes search requests to the indexers and merges results back to the user. So when you send search requests through the search head, that's what is happening in the backend. There could be multiple indexers back there, it could be one. But then the search head is going to distribute their requests if there are multiple indexes. When the results are coming, it's merging them back to you on the search head. But that's very invisible for you because you are just seeing your search results. You don't know the underlying details of what is happening in the backend. So we've been talking about Splunk users connecting into Splunk and then, running their searches, doing their analysis and visualizations. The clarity now comes here when you're connected. What is happening is that you are connected through a search head. So if you are just a Splunk user, the underlying details of the indexing process, and maybe when it even comes to ingesting data with the forwarders and all that, those are not of concern to you. As a Splunk user, all you are interested in is connecting to the search head and then doing your search analysis, visualizations, creating knowledge objects, dashboards, and things like that. Now, again, just as we saw, we're going to see the concept of search head cluster here, just as we saw with the indexer cluster. It's exactly the same thing. So if you are only connected through one search head and then that search head happens to fail, Your data is actually sitting in the indexers, but there is no way for you to run searches. So what happens in practice, in again bigger deployments, is that you group these search heads together in what we call a search head cluster. So when you have a search head cluster, the idea is to have identical configuration. So this just means that anytime you're connected, you could be connected to search head 1 or search head 2 or search head 3. You don't even know, but you are still running your searches and getting exactly the same results because those search heads have identical configuration. And then search requests from users are balanced across the search head cluster group. So now what you're trying to say here is if you had, say, 5 search heads in a cluster and then you are running searches, what happens is that users that are trying to access that search head cluster are going to be distributed equally across the 5 of them so that there is a balance. That means that, each search head out of those 5 is going to be taking like 20% of the traffic. But if you are not balancing your data, then maybe one search head could be getting overwhelmed and then the others are not used as much. When you continue your journey in Splunk, you're going to come across, if you're talking search head clusters, what we call a load balancer. So you use a load balancer to do something of this nature, where you balance, requests or information across multiple search heads. Now, how is the search head cluster managed? So when you have search heads in a cluster, you have one of the search heads is going to act as a cluster captain. This is not something like the indexer cluster manager that we saw before. It's not a separate component. It's just one of the search heads that can act as a cluster captain. So what it's going to do is going to be coordinating job scheduling among the search head members, and then it also coordinates replication activities. Again, because we said that they need to have identical configuration. So there's replication as well happening across those search heads. Now, we talk about the search head cluster deployer. This is now a management component. So you have all these search heads in a cluster. If you wanted to deploy something, maybe some apps or some content, you will not want to start going one search head after the other because it's prone to mistakes and it takes several maintenance activities as well. So that is where the search head cluster deployer comes in. You can actually use that to deploy apps and other configurations to members of your search head cluster. All right, let's talk about the deployment server. So the deployment server is a Splunk management component that you can use to deploy, apps and other configurations to groups of Splunk instances, just as the name implies. So you can distribute content, configuration apps to other Splunk instances, being it indexes that are not in a cluster, search heads that are not in a cluster, forwarders. And all these instances that you deploy to are what we call deployment clients, because your server is sitting there like a central server, and then you are deploying information from there into instances that you're going to call deployment clients. And when you take all these content, configuration, and apps, you can group them together. The general name you see associated to this is what we call deployment apps. So when you want to deploy something from the deployment server into a group of instances, you're going to call that bundle as deployment apps. In practice, though, you're going to see that the deployment server is heavily used with Splunk forwarders. And this is for a good reason too. So if you purchase Splunk and then in your network, maybe you have thousands and thousands of hosts, you wanted to collect data from those thousands of hosts in order to send the data into Splunk. So you decide that, okay, I'm going to do that by using forwarders. So you install forwarders on those hosts. Maybe you have different operating systems. You have Linux, you have Windows, and that you install forwarders on all of them. Now, if you wanted to distribute content to all of this and you never had a deployment server, and then maybe you have to split them and then do them one after the other, or one group one night, one group the other night, or just depending on how you handle this. But you see that it's going to be error prone and then it takes way too much time. That's why you see that for this reason, the deployment server is mostly used with forwarders. Let's take a good example here. We can have, maybe let's suppose that we have a network where we have Windows hosts, and then we've installed forwarders on all those hosts, maybe 100 plus or maybe 1,000 of them. And then we have another group that is Linux hosts, and then we have forwarders installed on them. So what we're going to do with the deployment server is that we're going to take deployment apps that are associated with Windows, and then we deploy these deployment apps, which is our package that we have, on all the Windows forwarders, and then we can do the same thing as well for all the Linux forwarders. So that's a typical example of how you can use the deployment server. That's why we say that we can use it to deploy apps to groups of Splunk instances. Here you have two groups. You have Windows hosts and then you have Linux hosts. Now, when you have your deployment server, of course, you need to be able to manage that deployment server. So you're always going to see the term known as forwarder management or sometimes deployment management. So this just basically means that that's a way that you can use in order to manage your deployment server. And forwarder management comes as a part of your Splunk web. So when we're going to install Splunk, we'll go into the Splunk web interface. There is a part of the Splunk web interface that is used for the deployment server. It's used to manage the deployment server, and that is what we call forwarder management. And when you go into it, it provides you a way that you can configure this deployment server. So you wanted to bundle these apps and send them to a group of Splunk instances somewhere. You can do that kind of configuration there, and then you can also monitor updates. Now, before discussing the license manager, let's just talk a little bit about Splunk licensing. So when you say that you purchase Splunk, what do you actually mean? So maybe you downloaded a trial version of Splunk, you tested it for, 2 months or so, and then you wanted to go ahead and purchase Splunk. So basically what you mean here is that you're paying for a software license. And that licensing comes, with different categories. The first one here is what we call the volume-based license. So the volume-based license, you are licensed to use to index a certain volume of data in a day. So your license might state, for example, that you can ingest 10 terabytes of data in a day, and if you start ingesting beyond that, then you are going against your license capacity, and you ultimately need to talk to Splunk to increase your license because you are no longer compliant. The next one is the infrastructure based license. With this one, instead of looking at the volume of data that you are ingesting in a day, you're looking at the resource usage in terms of virtual CPUs. So you are licensed to a certain capacity in terms of how many vCPUs you can use. So you need to keep below that limit, because if you start going beyond that again, you are no longer compliant with your license. The third thing that licensing offers is access to Splunk features. So it's not only about volume of data, it's not only about vCPUs. There are certain features that you cannot use, for example, if you don't have licensing, if you don't have the license to use them. For example, we spoke about a deployment server in the previous slide, and then we said that you can use the forwarder management, which is part of your web Splunk web, in order to manage the deployment server. So if you don't have such a feature associated with your license, you're not going to be able to use it. Now, if you download a single Splunk package and maybe just install on your machine, like you're doing a trial or something like that, it comes with its own license already. Now, let's think about in your deployment that of Splunk, where you have your instances that are spread across multiple machines and they are just sitting there. And then are you going to now go and say each instance has its own license, this one has its own license? Then how are you going to be able to calculate that volume of data that is being indexed in a day if we are talking about volume-based licensing? That is where the license manager actually comes in. So you're going to take all those Splunk instances and point them to the license manager, because the license manager has to keep track. Now let's look at it this way. These are indexers, for example. And these indexers, each of them is indexing a certain volume of data in a day. And then there are 10, 15, 20, 30 of them. So they are all reporting to the license manager so that the license manager can get the aggregated volume of data that is being ingested or indexed in a day and compare it against your license volume. So the license manager, what it typically does is it hosts licenses and it's going to assign this license volume to Splunk components. So all these components we talk about that they are connected and communicating with the license manager are what we call the license peers. Now, we just spoke about indexers and saying that the indexers are going to be associated, connected to the license manager. What about the search heads, for example? In real time, they are not really ingesting any data. You are just using the search heads to search your data. But then they're also going to be connected to your license manager. Why? Because there are certain features that you're not going to be able to use in the search head if you don't have the license for them. Now, within the license manager itself, you're going to see what we call stacks. So this just means you purchase a license and then you purchase another license. These licenses are all going to be stacked together. And what typically happens is that you can configure license pools from these stacks. And these license pools ultimately are what your license peers or the components are going to connect to in order to get the license volume that is required. So we've been talking about Splunk more about ingesting data into Splunk and then searching, analyzing, and visualizing this data. So you want to do some kind of analysis on your data, maybe using errors and saying, oh, something is happening here. But what if there are problems with Splunk itself? What if you cannot search? What if you cannot create a dashboard? How do you find out? So this is where the monitoring console comes in, because with the monitoring console, what you are doing is you are taking Splunk's own internal logs. These logs are found in indexes that start with the underscore, as we saw before. And then you are using these logs in the monitoring console in order to monitor your deployment. So basically what you are trying to do is that you are viewing the topology and performance information about your Splunk deployment. So if something fails, you're going to be able to see, because you are using these internal logs in order to have that complete picture. So the next thing here is that you have your monitoring dashboards that use data from this Splunk internal logs. So when you take this data as well, you can create dashboards from them. And this is a sample dashboard that you see here. So just looking at that picture right there, you are able to see your CPU usage, you are able to see your memory usage, you are able to see the number of concurrent searches that are being run. If something is actually going on wrong in your deployment, you will be able to spot that quickly because of the monitoring console. Okay, let's just clarify the difference between single and distributed deployment, because this is terminology that you're going to see, multiple times as you continue your Splunk journey. The first one we're going to see here is a single instance deployment. So when we talk of a single instance deployment, we are actually saying that your Splunk components are on a single machine instance only. So you take your package that you have downloaded and then you install on a single machine. That is what we call a single instance deployment. And then the instance can function as different component types. Again, as we saw before, I think we already gave this clarity. So you can, when you say that you configure an instance to be a Splunk component, such as an indexer, a search head, a deployment server, and whatnot, it doesn't mean that each component or each instance can be configured to function as one component. So in this specific case, for example, you have a Splunk instance on a single machine that can act as an indexer, a search head, and a deployment server at the same time. And then when you actually download the trial version of Splunk, it is an indexer and a search head already. Because if not, how are you going to be able to index data into that instance, and or how are you going to be able to search data? So typically, your Splunk trial package is an indexer and a search head already. And then for a distributed deployment, what you are really saying is that your Splunk instances are distributed across multiple machines. So you are taking your instance and then you want to really scale your deployment. So this is very, very typical in large deployments, commercial deployments, where big companies purchase Splunk and then they want to deploy Splunk. So you want to scale that deployment. You say, okay, maybe this instance I've installed here is going to be one search head. The other one is just going to be second search head. Another is going to be an indexer. The other is going to be the second indexer. I'm going to have a separate instance as a deployment server, and other components that we have spoken about. So basically, you are just distributing these components across multiple machines, and that is what you call a distributed deployment. Okay, so let's put together some of the things that we've discussed about Splunk components. Now, again, we start with our host machines, which have the data that we are interested in collecting and sending to Splunk. So if we are using Splunk components, we install universal forwarders or heavy forwarders on those machines to collect that data and send it to Splunk. There are times that you may also want to use a heavy forwarder as an intermediate forwarder. So remember, we said that the heavy forwarder can do parsing and some changes to data before sending the data out for indexing. So that actually reduces the heavy lifting on the indexing side. If you wanted to do that kind of thing, you can still place a heavy forwarder between your universal forwarders and the indexer, so that it collects that data from the universal forwarders, passes the data and makes other changes, and then sends that data out to Splunk. And then we also saw that in commercial deployments, companies typically will use hundreds to thousands of forwarders. So if you have so many hosts in your network, you're going to install all those forwarders. So it becomes difficult for you to deploy deployment apps into those forwarders. So that is where the deployment server comes in. It helps you to deploy those apps. And then there is a forwarder management interface that comes again with the Splunk Web UI that you can use to configure your deployment server and monitor updates. Now, when your data gets into Splunk, the component that receives the data processes the data and writes the data into this is what we call the indexer. So it writes the data into repositories in disks known as indexes. And we said that some of the things that happen during the processing, the indexer can parse the data if the data was not parsed before. It can assign timestamps, it can assign metadata, and other things. Now, in environments where you need like high data availability, you want to make sure that you have access to your data set at every single point in time. The idea is to group your indexes in what we call the indexer cluster. So when you have the indexer cluster, the idea is to replicate, you are replicating data. So when an indexer is indexing and writing data to this, you are replicating that data across other indexers so that when an indexer fails, you still have access to the same data set. When you have this kind of configuration, then the management component that manages this cross cluster and controls those replication activities is what you call the indexer cluster manager. And then we spoke of licensing as well. So licensing actually controls what you use and what are the features that you have access to. So if you have a volume-based license, for example, these indexers, as they are indexing data, there are reports that are going to the license manager that now gets the aggregated data volume and understands like how much data you are ingesting in a day, and then comparing that against your license. And then we also said that license control access to features. So there are other Splunk components that are not necessarily indexers that are going to connect as well to the license manager, because that's how the features are going to be open to use on those Splunk components. So once your data is available in Splunk again, now what you need to do as a Splunk user is to search the data. In order to search the data, you're coming through the search head, and then you are running commands that the search head takes those commands or your queries and then sends to the indexers, gets the data and presents the data to you as the user. So here, for example, you see a typical user that when the user ingested the data, said, okay, my source type, my data type was like JSON. The host from which I got my data was host 1, and then I'm just interested in looking for events that have the username James in them. So you run that kind of query, it's going to give you events that actually match that criteria, but it goes through the search head, pulls those events from the indexes through the indexers, and then presents those results for you on the search heads. And we also saw this concept of the search head cluster, where we said that if you want to make sure that you can always search your data at every single point in time, so that if one search head fails, you still have the ability to search your data, then you have to group these search heads into a search head cluster. We saw that one of the members of the search head cluster is going to act as a cluster captain, but we also saw that there's a management component that is known as a search head cluster deployer that you can use in order to deploy apps to members of that search head cluster. So we've come to the end of our topic on Splunk components. So in the next video, we're going to be discussing Splunk deployment. So whoever is purchasing Splunk, being it just a user or maybe some business, there's generally characteristics such as the volume of data that you're going to be ingesting in a day, because, you know, in case of volume-based licensing, that's very important. Maybe the type and number of searches that you're going to be running, how many users are going to be connected to that system concurrently. Are there any high availability needs, such as you're going to require indexer clustering because you want to make sure you always have, you know, access to your data, and all those kind of things come into play. So when you take all these things into consideration, there are recommendations on the kind of deployments that you can have. And these deployments are basically just taking the Splunk components that we discussed and grouping them together. So there are different types of deployments. Some of them are just like basic deployments, which is basically the single instance that we saw before: small enterprise, large enterprise. So that's what we're going to discuss in the next video. See you there.